Okay, let's go ahead and get started. Welcome everyone to our GIA Knowledge Sessions. These are a series of talks and seminars about gemology that are fueled by our decades of research. And you know, at GIA, we're so lucky and we're so excited to be able to study and learn from gems every day. And it's our mission to share our discoveries with all of you. So I'm really excited to kick things off today. I'm Kelly Giordano, a member of the content team here at GIA. And I'm joined by Dr. Wuyi Wang, Vice President of Research and Development at GIA. And he'll be giving us an update on laboratory grown diamonds from China. So before we get started, there's just a bit of housekeeping. Everyone attending this is automatically muted. So if you have a question, please use the Q&A feature at the bottom of your screen. Feel free to ask questions as we go, and there will be a Q&A session at the end where Wuyi will have the opportunity to answer some of your questions. We'll also send a recording of this session to you later today or early tomorrow morning, and that message will also have a short survey, and we'd love to hear your feedback. And so with that, I'm going to pass you over to Wuyi.
Thank you, Kelly. Hello, everybody. It's really exciting for me to have this opportunity to talk to you. Thank you very much for attending. And today I'm going to take this opportunity to talk about the diamond growth in China. As you probably know, start about 4, maximum 5 years ago, suddenly there are a lot of lab-grown gem diamonds showed up in our jewelry market. We may be wondering what happened, why could suddenly in China so many lab-grown diamonds, gem quality could get into the market. So I'm going to talk about the industry, diamond growth industry in China today, instead of talking about a stone itself. That Dr. Michael Breeding talked about the spectroscopy, gemological features of the diamond a few weeks ago. So in my talk, I will use the term lab-grown, and sometimes I continue to use the term synthetics. I mean the same thing, referring to this diamond produced by mankind, by human being, in the laboratory or in the factory. Let me start from this map. China is a big country. In the East Asia, it has a huge population, 1.3, 1.4 billion people. Most of them stay in the east part of China. The Chinese people, they like gems. China is probably the largest market for jadeite from Burma, from Guatemala, and China is the second largest market for gem diamonds. The interesting thing in China itself, like China does not have many gemstones from China itself. The well-known gem material is probably freshwater cultured pearls. China produces a huge amount of high quality freshwater cultured pearls with top quality and a very affordable price. I'm talking about it. Why I'm talking about the pearls, because today I'm going to talk with you is the lab-grown diamonds from China is probably another product that is a parallel to freshwater cultured pearls. Will be high quality, eventually will be an affordable price. China has many levers. In the map, you can see one country is Afghanistan. I mentioned Afghanistan specifically here is China has one thing similar to Afghanistan is the war. You know, the war continues, has been continuing Afghanistan for decades. Same thing in China, the war continued for over half century until late 1940s or very beginning of 1950s. When the war finished, the country started to rebuild the country, to industrialize the country. Among many things China needs, one thing is a diamond. Diamond is critical for industrialization. But in that time, there's no much opportunity to get the diamonds from the international market. So first thing China did is in 1952, China started the diamond exploration, tried to find if we could get natural diamonds. So the first kimberlite, diamond-bearing kimberlite, was found in Shandong province in 1965, like 13 years after the start of the diamond exploration. So here's where the Shandong province is. And in 1971, in Liaoning province, Liaoning province is here. So mining started immediately after the discovery of this diamond-bearing kimberlite rocks. The picture at the lower left is the two pictures. Actually, it is the first kimberlite, diamond-bearing kimberlite China discovered in Shandong province in 1965. It is not a pipe, actually it's a dike. It's like a vertical, very narrow rock body extended for kilometers. So I took this picture in mid-1980s when I was studying geology in China. And the picture at the right-hand side was a pipe about 1 kilometer away from this dike. So this was a picture I took in 1980s. And the total production in China for natural diamond, the peak is about 150,000 carats per year. But that is definitely not enough to support the industry there. So China has to start another option. That's a very good news. In 1955, the GE scientist published a paper in Nature. They use HPHT technology, that is a high pressure and a high temperature technology, to grow diamond in the laboratory. That's extremely important breakthrough in technology. So China launched the experiment to grow HPHT synthetic diamond. I'm using synthetic term here in October 1960. So it's about 5 years after the publication of this paper. And the first diamond was produced in December 6, 1963 in Zhengzhou, almost 3 years after they launched this project. Zhengzhou is the capital city of Henan province in China. And the interesting city, I'm going to talk more about it later. To grow diamond at a very high pressure, high temperature, that's HPHT, we need a press to generate very high pressure. These are the two very well-known press in Japan. The left-hand side one is in a National Institute in Tsukuba in Japan. The right-hand side one is a press in Ehime University. They use this to grow NPD, nanocrystalline diamond. The press basically is something of two pieces. The top part is fixed here. The lower part is a piston that is movable, can move up with the oil pump. That the part will touch the fixed upper part, generate the high pressure with a very heavy load. For this press, it has the load can go 30,000 tons. For this one, the right-hand side, it can go to 6,000 tons of load. So when the two pieces touch each other by oil pump with 30,000 tons of the load, you can imagine a huge pressure is generated. An interesting thing is a type of press in terms of design principles. The pressure is coming from one direction because the piston is moving up and down, so they generate uniaxial pressure. This type of principle press has been used in Russia, in Japan, in Europe, and by De Beers and by Sumitomo to grow diamond. China used an entirely different concept of press design. In 1965, they invented a unique cubic hinge press. Instead of using one piston, they use 6 pistons, 4 in horizontal direction and 1 up and 1 down. So these are 6 arms or 6 pistons are joined together with a hinge. So it's a very interesting concept and designed specifically to grow diamond. This is what the press look like. The first interesting thing is this press is in a diamond shape because it has 6 pistons. The press itself just looks like a diamond. So to design a press specifically to grow diamond and in a diamond shape is kind of an interesting coincidence. The press moves in 6 directions perpendicular to each other. That generates this type at the center when all the pistons join together, create a cubic shape. So the carbon, basically graphite, and the catalyst, the metal catalyst, is mixed and put into this cube. And a very high pressure and temperature, the graphite will convert to diamond. So that's very simple. Now I said it looks like very simple, but it's a complicated design. So at a very high pressure, high temperature, at the cubic center, the graphite turns to the diamond. One interesting thing I want to emphasize is it's a very important concept for a press is the diameter of the piston. The bigger the piston is, the more powerful the pressure is going to generate. And because to grow diamond, we basically need a 5 to 6 GPa. With a large power, would be able to use a bigger cube. That means we can grow more diamond in one run. So that's very important. So a very important parameter for a press is the diameter of the piston. Usually the press are very big. This press is about 4 meters high, so like about 2.5 people that tall. It's very big. This cubic press designed in China uniquely for diamond synthetic has some interesting features. So I just summarize some interesting features here. It has 6 independent anvils and a very durable, long lifetime, very easy to do maintenance. An important feature is the pressure is generated in the cubic form because it has 6 pistons. It's a dynamically symmetrical, and it's also highly reliable and controllable. And the most important thing for production, for mass production, is this press can quickly increase and decrease the pressure. So that means you can easily be more productive in instances in growing diamond. Very easy to operate, and it's a low cost. So this press was designed in China for China only, but since the press works really well for diamond synthetic, so you probably know the Russian, the very famous company, New Diamond Technology. They grow very large HPHT lab-grown diamonds and the colorless blue color with the 2B type 2B. They use this type of a press for their diamond synthesis. China uses this press to grow at beginning not a gem diamond at all. It's a diamond like this. The yellow color, very small but high quantity crystal. The size of this crystal is less than 0.5 millimeter. So this scale bar is 500 microns. So crystal is less than 0.5 millimeter in size, but high quality crystal that's good enough for industrial application. So they use this press to grow diamond for industrial application, nothing to do with the jewelry industry, for cutting, for polishing. So in 1965, about 10,000 carat diamond was produced by this technology. That's the same time when first diamond bearing kimberlite was discovered in China. By 1970, 500,000 carats were produced in laboratory, in factory, I would say. In 1980, 45 million, 1985, 5.5 million carats. So you see China quickly built up the capacity of HPHT synthetic industrial diamond. These stones show yellow color because they captured some nitrogen impurity during diamond growth, but pretty beautiful color. Some of them could be even green due to high concentration of nitrogen. So in fact, in China, you'll see buckets of small, tiny diamonds like this in the factory. Over the past half century, China built up a very big capacity of HPHT synthetic industrial diamond. Totally have about 600 factories distributed all over the country. But there are three major ones, bigger players. First one is Zhongnan, and I put the website here. And the second largest is Huanghe, and the third one, the largest, is a Sino Crystal. This is the number one, number two, number three largest factories in China, and also they are the first, second, and third largest in the world. So these are the very large factories, and this factory, actually, we talk about the city Zhengzhou, the capital Henan province. This is the center in China for R&D of a diamond industry in this city. So all of the three largest factories are within drivable distance around this city. So it's very easy for us when we want to visit the factories, just fly to Zhengzhou, and then we can drive to each of these factories. These pictures just show you what one of the factory look like. It's a huge factory, very well maintained and managed. These buildings are where their press are housed. It's so many buildings and very, very big. If you look at inside, this is what the inside of the factory look like. These are press, same press, cubic press, and they are standardized. As you can see, they are all same design and highly automated. So in the factory, we don't see, when we visit the factory, we don't see many operators in the factory, just a few of them. They can run a very big factory, fully automated. I like to use this diagram to summarize how much HPHT synthetic diamond is produced in China. So this red dots shows from about 2010 to 2019, about 4,000 tons of HPHT synthetic industrial diamond. I try to emphasize the industrial diamond is a small tiny crystals produced in China. But at the same time, I was going to show for comparison, globally, the natural diamond mined from kimberlite or from alluvial totally is about 35 tons only. So the synthetic diamond, industrial diamond, is about 100 times more than natural diamond. So China, over the last half century, built up keep improving their technology, growth technology. They built up a huge capacity, and it took over 90 or 95% of the global market. So the market share for other producers like De Beers in South Africa, Irrigation in Korea, and US synthetics in the United States, the share keep dropping to a very small percentage. Meanwhile, the price of the synthetic industrial diamond dropped very much from early days of 7 cents per carat to now about 5 cents per carat. So China has a huge capacity. That capacity is bigger than the market needs. So it's very, very easy for Chinese industry to think about to grow gem quality diamond, large crystals, in addition to is a small industrial quantity in diamonds. Actually, China had a pretty long program to develop the technology to grow large crystal gem diamond. It began like it started in 1980s for the first time in Shanghai. There's a very famous institute in Shanghai called Shanghai Institute of Ceramics. They produced the first large diamond up to about 3 millimeters in size. but with poor quality. And then it's up to waited until beginning of 1990s. A state key project, that means the government sponsored is a project to develop the growth technology for large single crystal of diamond. But it didn't go very well. The project actually was suspended due to the poor performance, poor progress of the project. So study the technology to grow a large diamond is until end of the 1990s. There are some systematic studies in the universities in China. But when we look around where the technologies are in terms of growing large crystal diamond, in Japan, yes, they have HPHT technology to grow large crystals. In Sumitomo, in the National Institute, and in some other areas, Japan. In Novosibirsk of Russia, they have very good technology to grow large HPHT synthetic diamond, and in Kiev of Ukraine, and in the various United States, the various United Kingdom, and of course United States, and GE have the technology to grow large crystals. In these countries, their strategy looked like to grow large, high quality, gem quality diamonds. But China, they took an entirely different approach at the beginning. Instead of growing very large gem quality, they grow the gem quality crystal up to about 2 millimeters. We use the yellow industrial diamond as a seed. As we know, to grow gem quality diamond, we need a seed. It's a really cute design to use the very small industrial diamond, of course, well orientated with a cubic face here, 100 cubic face here, to grow a gem quality colorless crystals to around 2 millimeters. Very small crystal, but it's good enough to cut into a many gem diamond. So suddenly, in the gem show, we see a lot of beautiful small HPHT synthetic gem diamonds. And this diamond will cut somewhere in the world into many diamonds from half point to 1 or 2 point in size, round brilliant, or sometimes a fancy shape, get into a gem market. I believe most of them are marketed as synthetic, as HPHT lab-grown diamond, but some of them were mixed with natural many stones, intentionally or unintentionally, and create a huge concern in our jewelry industry how to screen these small diamonds out from natural stones. Just some brief summary of the many diamond production in China. It started from 2014. The Sino Crystal Diamond, that is the number 3, the last company, started selling, the developed technology started selling this many diamond. They're type 2A, about 1 to 2 millimeters in size. And they produce about 10,000 carat per month in 2014, with a price about $60 per carat. So GI was following with them immediately. In the second half of 2015, there's more than 10 factories in China in that area, surrounding Zhengzhou, that area, so producing the similar product. And in the second half of 2016, the production reached about 200,000 carat per month. So you see the capacity, the production increased significantly within a very short period of time, and the price dropped to $15 US per carat. So I mentioned this just is a very similar parallel to the culture, freshwater culture pearl story that happened in China as well. It's a good product, but it was a very affordable price. They keep improving the quality of these many small crystals. In this picture, as you can see, 2 to 3 millimeters crystal, very, very good color, very good clarity. So we'll be able to produce excellent many diamond. In addition to these very small crystals, in 2016, China also tried to develop to grow large crystals. These are some pictures with stones actually GIA obtained from a factory in Shandong province. This crystal is getting close to 1 carat, from half carat to about 1 carat in 2016. But in 2018, as you can see in the gem show, you'll be able to see some rough diamond, 3 carats to 5 carats in rough, HPHT synthetic, and faceted from a 1 carat, 2 carat to up to 3 carats. So only within 2 years, you see the technology improved a lot, generated top quality, generated this synthetic diamonds with a quality comparable to natural top quality diamonds. I like to use this form to summarize some major features of gem quality diamond synthesis in China. So in the first column, I list the 3 major factories: Zhongnan, Huanghe, and Sino Crystal. That second column is the number of a press. Like Zhongnan have a 3,600 press. Huanghe has a 2,500, and Sino Crystal have 800 press. So simply put these 3 together, it's more than 7,000 presses. So China has totally over 10,000 press, a huge capacity. Is the top 3 together totally have more than 7,000. The third column shows the diameter of their piston, basically show how big their press is. Like Zhongnan use a medium size, 600 millimeters, and Huanghe is a small one, half meter, that's 500 millimeters, and the Sino Crystal use a very large one, 700 millimeter diameter. They allocate a good amount of their press to grow gem diamond. Like Zhongnan have 1,300 press for gem diamond growth. Huanghe have 200, and the Sino Crystal 400 to grow gem diamond. So they have a technology to grow 3 to 5 carat, 2 to 3, or Sino Crystal grow relatively small crystals. This table is summarized in 2018. But now I know for Zhongnan, they can easily grow up to 10 carat, very high quality diamonds. So just to give you some idea about their capacity and the crystal quality, like Zhongnan is probably the best, followed by Huanghe, and then followed by Sino Crystal. So in terms of how much HPHT synthetic gem diamond China could produce, it is probably just up to the market. They can easily switch the price from here to grow gem diamond. They probably can grow as much as the market needs of the synthetic diamond. So up to here, basically, I reviewed the industry over the last half century in China that built up the capacity to grow a huge amount of industrial diamond for industrial applications. But it's only until 4 or 5 years ago, they used the same equipment, the facility started growing gem quality diamond for our jewelry industry. That basically finished my talk about HPHT synthetic diamond in China. I'm going to take a few minutes to talk about the CVD synthetic diamond in China. This is not this picture doesn't show anything from China. This is a CVD laboratory in GIA. GIA is probably the only institute, or only laboratory in the world, gem laboratory in the world to grow CVD diamond. This picture, I took it immediately after we set up the lab. As you can see, everything is perfectly clean. But now it's much more busier. If you go to the SEM lab, it's very busy because we grow a lot of good quality diamond. CVD is an entirely different technology comparing with the HPHT. CVD basically grow in the vacuum with a moderate temperature. As this picture, you can see the blue color from the reactor. That is plasma generated. That in the plasma, the gas basically is a hydrogen gas, and the methane gas will react. The carbon in the methane gas, from the methane gas, will deposit on a seed of diamond as another layer of diamond. So this is an entirely different growth process if we compare that with the HPHT in growth. China also invests very heavily in CVD technology. There's three major players. One is the Shanghai Zhenshi, another one is Limbo Crystal. Both are in this area close to Shanghai. And the third one is the Xi'an Sea Star, it's far away in the west part of Xi'an. These are the three major players. In addition to these three major players, there are many factories and institutes that are investing or doing R&D for CVD growth. This is a picture I just want to show you what kind of quantity of CVD diamond can be produced in China. This is by the Zhenshi technology. As you can see here, the CVD diamonds faceted up to 5 carats with a top quantity of color and very high quantity of very good clarity. So CVD in China are producing very good quantity of gem diamonds for our market. Color is very important for natural diamond. The same thing is color is very important for synthetic, for lab-grown diamonds. So China is performing some post-growth treatment for their lab-grown diamonds applied to both CVD diamonds and HPHT diamonds. They including use HPHT annealing to remove the brown color of CVD diamond, and also irradiation followed by annealing to create pink color. So China at this moment, as far as we know, they are trying to improve the color appearance of their diamond and try to create, focusing on pink colors and the blue colors. I'll touch a little bit of the price. In Hong Kong show last year, 2019, this basically is the price they offer for the synthetic diamond. The top color, EF color, VS and plus clarity, size from 2 point to half carat. Price is about $160 US to $630 US. And this just want to show you because about 2 years ago, Lightbox announced they're going to market their CVD synthetic diamonds with a flat price $800 per carat. So the Chinese products are still far below the price that Lightbox is offering. GIA invests very heavily in studying synthetic diamond, lab-grown diamonds for identification. We are able to identify every single synthetic diamond. It doesn't matter if it's HPHT synthetic or CVD synthetic, large or small, with or without post-growth treatment, mounted or loose. So I just use this slide basically to show some features, main features for us to identify HPHT synthetic lab-grown diamond. The interesting feature, I think, most important things, I'm not going to go through all of the items. The most important feature for HPHT lab-grown diamond is a strong blue phosphorescence to short-wave UV, and also the very characteristic growth pattern. Just be careful, the blue phosphorescence could disappear in an HPHT synthetic diamond by some treatment. Somebody is intentionally developing technology to remove this phosphorescence feature. And also this growth pattern, like I show here, could be very, very subtle. With the improved technology in China, this type of a growth pattern is very hard to detect. So need to be careful to identify HPHT synthetic diamond. For CVD synthetic diamond, the main feature is basically the growth pattern, the growth of striations, and the occurrence of a 737 nanometer emission peak from silicon vacancy defect that can be detected by photoluminescence spectroscopy. So anyway, in GIA, we have the confidence we can identify every single synthetic diamond. I want to use this slide to summarize my presentation today. This is the second to the last. Basically, I talked today about the Chinese, very briefly about the Chinese natural diamond exploration. It started from 1952, and they find some natural diamonds, but not enough for the industry in the country. And from 1960, they invested very heavily in producing industrial-grade diamond and build up a huge capacity, the bigger than the need, than the whole global need, the capacity to grow industrial diamond. So about 5 years ago, 5-6 years ago, that capacity, part of it will be used, transferred to grow gem quantity diamonds and for jewelry industry. At the same time, some CVD technology have been studied, invested, and to grow diamond for jewelry industry as well in China. I touched very little about the identification feature for its lab-grown diamonds. I just want to emphasize GIA has a full capacity to identify every single of them. I want to use the last slides to do a very brief advertisement. Since there are so many synthetic diamonds, lab-grown diamonds in the trade, big and small, not every stone can be submitted to gem lab for testing. GIA produced this very small portable device for diamond screening. It's a very special device. It's not only the screen colorless, near colorless ones. It also is probably the only one in the world that in the trade that screen fancy color diamond like brown, green, blue, and pink. It can very effectively separate man-made lab-grown diamonds from natural diamonds. With that, I want to thank you very much, and I would be more than happy if you have to answer if you have any questions. Thank you.
Thank you, Wuyi. That was great. We did get a lot of questions, so I'm going to jump right in. How long does it take to produce a diamond, both with HPHT and CVD?
I would say, I don't exactly. I think for, let's say I use a 1 carat faceted round brilliant as an example to grow, use HPHT technology. I would say a few days. For HPHT technology, similar thing could be up to 2 weeks for CVD technology.
Okay. If the synthetic diamond is grown from a natural diamond seed crystal, how come the finished lab-grown diamond is not considered a composite or some kind of doublet?
Well, let me separate HPHT synthetic and from CVD ones. So HPHT technology grows that can start from a natural seed. They can also start from another synthetic seed. Actually, in China, they use synthetic as a seed, and the seed will be removed after the growth. So there's no way for the seed to be faceted into a jewelry, a piece of jewelry. So there's no issue for like a hybrid, a diamond. But for CVD diamond, we can use a layer of CVD as a seed. We can use a layer of HPHT synthetic as a seed, and we can also use a layer of a natural diamond as a seed to grow whatever thickness of CVD above it. And this seed does not have to be removed. So let's say you have a same color CVD and grow another layer of CVD, perfect. So just cut it, make the gemstone. But if we use a same color natural diamond to grow another layer above it with the same similar color, and then facet it, we would have a hybrid diamond with a partially is natural and a partially CVD. Then that will be an issue, and it's an issue for identification, and it's also an issue how to call these stones.
Okay. There's been some conversation about color instability in laboratory grown diamonds and a higher incidence of chip stones in laboratory grown diamonds versus natural diamonds. Has GIA found this to be the case?
Yes, I think for it's basically a concern for CVD synthetic. I think CVD synthetic diamond may have some defects that are not stable, because we know all color of a diamond is come from defects. That's optical centers. CVD diamond may have some unstable optical centers that could make the diamond color not very stable. And the CVD diamond also have a very strong internal stress. I think that could be the reason make it easy to be chipped. This would not be an issue for HPHT synthetic diamond. HPHT synthetic diamond color is very stable, and they have a very high quality in terms of crystalline. For example, have a very low internal stress, so that chipping will not be an issue for HPHT lab-grown gem diamonds.
Okay, so how big can any of these laboratory-grown diamonds get?
Well, we saw some lab-grown diamonds after fasting above 10, 15 carat already. We test quite a few of them in GIA laboratory. And we saw pictures of some as grown crystal using HPHT technology up to 100 carat. So I think it is just a matter of time. This crystal could get bigger and bigger and quality getting better and better. That's for HPHT growth. For CVD, I think what we tested is probably 6 or 7 carat after fasting. That's probably the biggest crystal we tested. I haven't seen a real gem quality CVD diamond rough up to 100 carat yet. I'm not saying that's impossible, but it's quite challenging to grow a uniform in color or in quality a very large CVD crystal. It is still not easy at this moment.
Okay. Why is there nitrogen usually present in laboratory-grown diamonds?
Good question. I think let's use HPHT growth as an example. So nitrogen is the highest concentration of air. Most of the air is composed of nitrogen. So when you put a lot of components or parts together in the assembly to grow HPHT synthetic diamond, you can imagine there are a lot of nitrogen included in that assembly. Some from air, some just as a part of the impurity in the material you're using. So during the HPHT, the diamond growth, the nitrogen would, some of the nitrogen would get into the lattice. Then that would create a yellow color. So it's very hard, it's not impossible, but it's very hard to entirely remove the nitrogen from the diamond. Sometimes you may be good enough to make the diamond entirely colorless. You have to use some special technology that got the getter. The nitrogen will go to the getter. But even though the diamond will still have a little bit of nitrogen, despite the diamond is entirely colorless. For CVD diamond, the CVDs grow in the vacuum. But when you talk about a vacuum, there's still a little bit of air inside the chamber. So nitrogen could be still a little bit as a contamination exists during the CVD diamond growth. Same thing as the HPHT synthetic, unless you try extremely hard to remove the nitrogen, otherwise you will get some parts per billion, sometimes even get a parts per million level of nitrogen as impurity in the diamond. And that nitrogen playing a very important role for the color of the stones. For example, they treat the either HPHT synthetic or CVD synthetic to pink color. Actually, they are taking advantage of the trace amount of nitrogen in this diamond to convert them to the right color center to create the pink or sometimes even red color for these stones.
So then is it very rare to get a colorless diamond, a colorless laboratory grown diamond without some sort of color treatment?
For HPHT synthetic, I think without any treatment, they can produce very easily. It's a type 2A entirely colorless in gemological term. Would get a DEF colorless. They still have a little bit of nitrogen, but in gemological engrading, it will be in our colorless category is a DEF color. It's very easy and technology is very matured. For CVD technology, in addition to impurities, there's some other issues in CVD growth, internal stress, and other optical centers. It is possible to grow CVD diamond like a DEF color, but we have to grow it very, very slow. But it's hard, very hard to grow commercially like a profitable colorless CVD diamond. Usually they want to grow fast, and then the diamond will be brown, then the brown color will be removed. Post-growth treatment is HPHT treatment to remove the brown color, and the CVD diamond will turn from brown to possibly colorless or near colorless. I think that very common for CVD technology to reach the G color or H color. It's okay to go to DEF, the technology is there, but the growth speed has to be very, very slow.
Okay. Is boron ever used to grow diamonds?
Yes, boron, when a diamond has a boron in its lattice, that's what is classified as a type 2B, like the Hope diamond, has a beautiful blue color. So during the diamond growth, boron can be intentionally added into the lattice that created the beautiful blue color. So it's a good mature technology in HPHT growth. So sometimes we can see a beautiful type 2B HPHT lab-grown gem diamond. And the boron concentration can be well controlled, so we can reach the right color we want. The biggest boron-bearing type 2B HPHT lab-grown diamonds we tested is about 10 carat in GIA state. So for HPHT technology, yes, it can be done. For CVD, theoretically, yes, you can also add a boron mixed with the gas. Then some boron will get into the diamond, CVD diamond, create a blue color. But I don't think it is mature enough, well developed enough for commercial production. We see some research samples with blue color with the boron in, but we don't see much of a commercial product that is a CVD synthetic type 2B with good blue color yet.
Okay. How many diamond crystals are produced in 1 cubic press at a time?
I don't know exactly. In China, they consider it as a secret for the large crystals. I'm talking about large crystals that probably grow multiple instead of growing one, because that will be much more profitable for large crystals. But for the many crystals, it is like 2 millimeters in size. Yes, they grow many in one run, hundreds of them in one run. What I heard is they can grow one run in 24 hours, up to 10 or 20, up to 10 carats. I don't remember correctly, but they can grow a lot of small crystals in one run in about 24 hours.
Okay. When was the 6-piston machine developed and first introduced for large-scale manufacturing of laboratory-grown diamonds?
It was invented in 1965, and then it is immediately started mass production used in China for HPHT industrial diamond synthesis. That's my understanding. So now they totally have more than 10,000 in China. And then that technology, that device have been distributed all over the world, in almost all over the world. In the United States, you can easily find the same type of a press used for growth or used for treatment of natural diamond in Russia and in some other area.
So then what led to the improvement of going from industrial to more commercial quality? Was it the actual machinery, or was it the process of using a seed, or was it some other factor?
I don't fully understand the question. You said from industrial quality to gem quality?
Yes, yeah.
Well,
Sorry.
For industrial quality, they grow a huge amount in one run, in very short time. They don't use seed. The technology for industrial diamond growth, there's no seed. It just apply the pressure, allow the temperature with the right chemistry in that assembly. a huge amount of a small yellow diamond will be produced in very short time. But to grow gem quantity diamond, that method cannot grow large crystal. It's impossible. So they have to put a seed very well oriented and very well control the temperature at the seed and above the seed, because a large crystal, they use the temperature grading the method. The controlling temperature, the convection of the metal catalyst is very important. So they have to put everything very accurately controlled. Otherwise, the crystal quality would not be good. So there's a huge process they need to improve before they can grow high quality gem quality large diamonds.
Okay. Which countries have been the most important for lab-grown diamond producers aside from China?
As far as I know, China is probably is the largest producer for HPHT lab-grown diamond. I think the total amount of CVD diamond produced in China is still not a very high. I don't know exact number, but for CVD producers in the world, I would assume Singapore is still very big, and the 2A technology, they claim they can produce 400,000 carat per year. I don't know exactly what is their current production. I think there are more and more CVD synthetic, very good gem quality CVD diamonds produced in India and probably many in Surat in that area. So India is a very large, will become larger and larger producer of CVD lab-grown diamonds for the jewelry industry. New Diamond Technology, this company in St. Petersburg, Russia, really demonstrated their unbelievable technology in growing a high quantity, large HPHT synthetic diamonds. But I don't know exactly how many carats they are producing, but it may not be very big, considering the total amount of the price they have. And I'm not sure their current production is continuing or not, but they have amazing technology in growing high quality crystals using HPHT technology.
Okay. You mentioned the GIA ID 100, and what would cause a natural diamond, like using machine like that, what would cause a natural diamond to not pass and to have the indication that they need to refer?
Good question. I think our device will pass 98% of natural diamond. That means about 2% of natural diamonds could be referred for further testing. Of course, 100% of lab-grown diamonds and simulants will be referred, but yes, about 2% of natural diamond could be referred. Why is this diamond, small percentage of a natural diamond could be referred? Because they are so similar in their impurities, I would say, or optical centers or defects in this natural diamond to these lab-grown diamonds. We have a spectrometer inside that small device that are testing, that detects some specific optical features of each diamond. And for this very special 2% of natural diamond, they showed very similar features as lab-grown diamonds. We try very hard to reduce, to minimize that percentage, but that's the best we can do right now. I hope in the future we can continue to reduce that percentage.
Great. You have mentioned SI defect possible in HPHT grown synthetic diamonds. I thought this was exclusive to CVD grown synthetic diamonds.
Yeah. So in the early days for this HPHT synthetic diamonds, yes, and let me go back a little bit. The silicon vacancy defect that usually we can detect using photoluminescence with a 737 nanometer emission used to be considered a very important feature of a CVD synthetic diamond. Some may even say, oh, this can only occur in CVD synthetic diamond. That's not really the truth. In some natural diamonds, we see that silicon vacancy defects too. So actually we published a paper many years ago. The beautiful silicon vacancy defect occur in natural diamond. In HPHT synthetic diamond, we were surprised when we first discovered it. Some of them have the silicon vacancy defect in early days, the early product, HPHT synthetic product from China, but not in the new product. The recent new product, concentration getting much lower, sometimes even not detectable. Why it happened, I don't know exactly. One possible reason is the starting material they are using. Let's say if the graphite they use to grow the diamond has a little bit of silicon in it, or from any other potential contamination, or even their growth recipe, trace amount of silicon could be incorporated into the diamond crystal in the silicon vacancy, that type of combination at a very, very low concentration, but still high enough to be detected by the photoluminescent technology. As we know, the photoluminescent technology is extremely sensitive in detecting some impurities up to ppb or ppt level.
Okay. Is there ever a risk that we'll get to a stage where CVD and HPHT are undetectable and we wouldn't be able to determine a lab-grown diamond from a natural diamond?
I think it's getting harder and harder to identify all of them, in particular when somebody tried to intentionally make it unidentifiable and to play a lot of games to introduce some defects of that usually occur in natural diamonds. I think that is possible, make it harder and harder. But I think I have the confidence we should be able to identify all of them, even with the improving technology, with this improved or intentional treatment to make it unidentifiable. I think we have the confidence we should be able to continue to be able to identify every single of them. It could get harder and harder, but it will be possible.
Okay. And so what is the principal detection in the GIA ID 100?
Well, it is a fluorescence spectroscopy, I would say. And usually we don't disclose that much, but it is a fluorescence spectroscopy. It has a very sensitive spectrometer inside. We detect a lot of fluorescence features from diamond, try to use that to separate natural from synthetic, and also from simulates. That's not the only feature we use. We use more feature than that.
And we can test, that machine can detect, can test mounted diamonds as well, right?
Yes, of course. It actually doesn't matter how big. We can easily analyze diamond is like a half point, like 0.005 carat each. For that small, we can easily test them.
Great. I saw a few more questions in the Q&A about the ID 100. So if you have any more questions or want to learn more about the device, just go to store.gia.edu and you can read up on all the product details and order one for yourself. That brings us just about to the end of the hour. So thank you so much, Wuyi, for joining us and giving us all this fantastic information about laboratory grown diamonds and the production in China. If you have any other questions for us at GIA, please find us on Instagram, Facebook, LinkedIn, and Twitter. And thank you all for coming. And I hope you join us again next week, where we'll be joined by Dr. Tao Su, who will give us an exclusive view of the jade auction in Myanmar. So thank you everyone for joining us, and see you again next week.